The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome to our webinar this morning. My name is Steve Comby. I'm with Frontier Precision, and I'll be your presenter today. The topic of today's webinar is the new RDO Blue optical dissolved oxygen sensor from In Situ. The RDO Blue is a third generation temperature and dissolved oxygen only sensor that they've manufactured. They started out, In Situ started out about 12 years ago with the RDO Pro, which was a small temperature dissolved oxygen sensor, and at the time it was a world-class sensor. Worked very well. After about 5 or 6 years, they saw some improvements that they could make, and they came out with the RDO Pro X. Primarily, it was having longer cap life on that sensor and still maintain the same form factor and technology. And then just a couple months ago, they came out with the new third generation, the RDO Blue optical dissolved oxygen sensor. So a lot of technology has gone into this, a lot of enhancements, and that's what we'll be exploring today. Before we get going, I just want to say that we do have to have everybody muted that's on the webinar today. That eliminates unnecessary background noise. Kids playing in the background, noisy coworkers, dogs barking, phones ringing, you name it. It all can happen when we unmute people. So we'll keep you muted throughout the duration of the webinar. If you have questions, you can see the questions box over in the pane on the control panel on the right side of your screen. So you can click on that button, type in your question, and at the end of the webinar, I'll read everybody's question aloud and reply to that question. So we should be able to take care of everything. You may want to wait till the end of the webinar to submit your questions because more than likely, hopefully we have some slides and information that will address everything. But if not, I'm very happy to address your questions at the end. So the agenda that we'll go through today is we'll discuss applications for temperature and dissolved oxygen measurement. We'll explore the technology behind the new RDO Blue, and then we'll talk about user scenarios, basically just use of the sensor in the most common applications. We'll look at options and accessories that go with this thing to make it more efficient and to make your life a lot easier when using this. And then, as we stated, we'll have a question and answer session at the end via the dialog box on the right-hand side of the screen. So let's get going. What is this sensor used for? So obviously, some of the most common applications are in aquaculture. And then within the aquaculture field, you have a number of different ways that the sensor can be used, such as inland ponds, open pens, recirculating aquaculture systems, and then in fish rearing facilities and hatcheries. And then on the environmental surface water side of things, you have dam monitoring. So this can be actual oxygen within the impoundment itself or downstream of the dam in the plunge pool area, and then further downstream from that. Fisheries habitat monitoring, so this can be with the sensor connected to a data logger or going out there with it connected via Bluetooth to your smartphone or tablet, and we'll get into that later so you can see how that all works. Discharge monitoring, a increasingly popular application of atmospheric deposition studies. And then in that marketplace, probably the very most common is in wastewater treatment plants. Dissolved oxygen is probably one of the more popular parameters measured at wastewater treatment plants so they can make sure all of the biological processes that they're using to clean up the water are effective, and that's all driven by having adequate dissolved oxygen in the system. So lots of applications for dissolved oxygen and temperature measurement. So let's talk about the technology now. So if we were to do a cutaway of the sensor and describe what's going on with this, basically you have two LEDs, a blue and a red LED, that shine onto the back side of this luminescing foil. And depending on the amount of dissolved oxygen that's present on the outside of this, you get a red return signal, and we're essentially looking at this phase shift that occurs in the return signal as opposed to the reference LED, and the phase angle shift basically gives you a very precise indication of the amount of dissolved oxygen that's present on this luminescing foil. The other thing that we want to state with that and emphasize is that years ago, In Situ went through a lot of lengths to take this technology to the US EPA and basically have their methodology for their measurement, so essentially their measurement processes, approved by the EPA. Now, we always have to clarify that the EPA doesn't actually approve sensors, but they're actually approving the methodology that we use for making this. So it's essentially by saying, yes, we have their stamp of approval on the technique that we're using to measure dissolved oxygen. Well, one other thing too, this technology that we're using here, luminescing or optical dissolved oxygen technology, has been widely available in the inland environmental marketplace at least since 2003, 2004, and in fact, In Situ is actually one of the primary companies that brought this into the inland water resource marketplace. It was in the marine environment before that, and this technology has really caught on. Previous to the use of luminescing or optical DO technology, the most common dissolved oxygen sensor technology was what was called a Clark cell or a polarographic sensor. So with this, you had a anode and a cathode at the top of the sensor. There was some electrolyte solution in there, and then that was held in place by a porous Teflon membrane that was stretched over that sensor, typically with a rubber O-ring. So it was a very good technology at the time, quite inexpensive. It was a little bit of maintenance intensive in that it required quite frequent calibration and replacement of those Teflon membranes on there. So at least monthly with most people, sometimes more often, you had to take off the old membrane, put new dissolved oxygen electrolyte in that Clark cell between the anode and cathode, put a new membrane on there, hold it in place, and then recalibrate everything. And a curious, I don't know if it's curious or not, but because of that technology, the sensor actually consumed oxygen at the membrane-water interface. So if you just held that sensor steady in a little bit of oxygen and looked at it over time, you'd actually see your dissolved oxygen readings decreasing over time. Not because there was actually less oxygen in that body of water, but at the membrane-water interface, oxygen was being consumed. So people that were using these sensors in portable applications, when they dipped it down in water, they kind of had to move it around a little bit and swirl it to make sure that there was adequate water movement across the membrane. And with stationary sensors, as they were placed in ponds or reservoirs and lakes, a lot of times they had mechanical stirrers or circulators mounted underneath there to make sure that there was water movement across that interface. So the thing that I want to emphasize with optical or luminescing dissolved oxygen technology is there is no oxygen consumed at the membrane-water interface. So you don't have to swirl these sensors when you're using them. You don't have to have natural or artificial movement of water past that membrane. And then the one other thing here too, there's kind of a marketing thing that they're using with this terminology RDO. Various companies have branded their sensors differently, but RDO is just simply an acronym for rugged dissolved oxygen. So if you see that in all of our literature and on our screens today, that's basically what that means. Other companies have called them LDO or other things. So people all have their little abbreviations for this similar type of technology. However, there's a lot of unique things that In Situ is doing with their optical or luminescing DO sensor that makes them very different from competing technologies that are on the market. And that's what we're going to look at right now. There's just what some of those differences are and why they're important to you, or why they should be important to you. So if we start looking at unique features, some of these are included in this cap. So basically what we're looking at right here is the removable, replaceable cap that slides over the top of that sensor that we were looking at in the previous slide. So the sensing cap has some foils that are bonded together in the top of it. And each one of these batches of caps that are created undergo really extraneous calibration procedures where there's a 90-point three-dimensional calibration that's put on this, looking at the phase angle, temperature, and the partial pressure of oxygen. So naturally, there's a lot of information that goes into this, but to make this easier for the user when they're replacing those caps, In Situ puts a really small internal microchip inside of this cap. So every 2 years when you replace a cap, you just pull the old one off, snap a new one in place, and that microchip does two things for you. It loads all of the new calibration coefficients for that cap, and it basically tells you the date and time it was installed. So anytime you connect to this, you can see, okay, hey, I've got 380 days left on this cap before I need to replace it again. Now, when a cap expires, it'll still read dissolved oxygen. You just won't be able to calibrate the sensor with an expired cap on it. So with some of our competitors out there, if you get a new cap, you have to hook your computer up to the system, put a whole lengthy string of coefficients in there. Not so with ours. You just simply snap it in place and it loads all the coefficients for you. The other really unique feature that's helpful in a lot of applications, especially if you're working in ephemeral rivers and streams, is we have instant hydration. With some of the competitors' technology out there, that lumiphore, that sensing material at the top of the cap, actually expands or swells when it's wet, and then it contracts when it's dry. So if it either in the office or out in the dry channel, if that cap goes dry, the instructions in their manuals are, hey, you need to rehydrate this cap for 24 hours or put it on a boilerplate before you can even calibrate it. So a unique feature of this is because of the formulation of our sensing element, the formulation is hydrophobic, so we don't require hydration and conditioning. And in fact, if that sensor is dry in the field, within 90 seconds, it can go from a dry to wet condition, measuring very accurately. So there might be a lot of applications where you can't control that sensor being hydrated all the time. So this technology that we're using makes that really unique. Another unique feature, because of the formulation of that cap or the foil that's on the top, is that we can measure oxygen in both liquid and gases. I'm sure most of our customers are only interested in measuring in liquid, but The important thing is that you can actually calibrate this sensor using water-saturated air or air-saturated water and basically see no difference in the calibration and subsequent readings. So kind of an important property and a unique feature of the cap. Another unique feature is the abrasion resistance of our cap. So this slide kind of shows a 3-layer cutaway of that foil or that luminescing sensing material, where on the very top you have a protective layer, behind that you have a protective backing, and then you have the luminescing layer underneath that basically reflects that red light back to the sensing diode. So this 3-layer system leads the market in both chemical and abrasion resistance. And importantly, if you're working in shallow water where you have bright sunlight on there, there's no effect from photo bleaching or inaccuracy from stray light on those sensors. The other important thing, because of that protective layer, is that the sensor is protected in high flow rates, especially if you have a lot of sediment in your water and it's rushing past that sediment can kind of create a scouring condition over time that if you don't have a really good protective layer and abrasion resistance, it'll basically scour that sensor right off. So there's no protection from sunlight or other things that can harm that sensor. In-situ also uses the same sensor on our multiparameter probes, where we have a mechanical wiping system that's centrally located and it spins around and cleans all your sensors. And with some of our competitors, that frequent wiping of their systems will take this coating right off of that. Not so with our sensors. So again, stands it very well with cleaning and high sediment across it. Another unique feature for those that are using the sensor with data loggers or SCADA systems is that the RDL Blue is a Modbus sensor with smart addressing. So it makes it really easy for you to swap sensors out at your sites to possibly take one into the lab or do other things with it without configuring your SCADA system. So we essentially have a 4-wire system, 12 to 36 volt DC digital Modbus RS485, and the register addresses are always the same. So it should be very easy for data logging or SCADA system setup. Now, a really unique feature about our sensor is the ability to have it connected to a data logger or a SCADA system out in the field. And then if you want to go around and do spot check measurements with pretty much anybody else's sensor out there, you would have to buy another sensor to carry around with you, and it would undoubtedly be a very different technology to do all of your spot checks or your dip and test measurements. With the RDL Blue, 1 minute you can have it connected to your SCADA system or data logger, undo the quick connect, put our wireless Trocom on there, which is a Bluetooth battery pack, and then you can just carry that around with your smartphone or tablet, see real-time readings in all of your ponds or tanks or rivers, record that data to your smartphone or tablet by tapping on the screen, and then email all that data back to your office. And then when you're done for the day or the hour, just take it back over and connect it right up to your SCADA system or data logger, and it would take off again. So really cool money-saving feature to help you out over time and give you a lot more versatility with your purchase. And then when you're using in-situ products, whether it's the wireless Trocom or our telemetry systems, we have what's referred to as a shared ecosystem. So in-situ has this Viewlink transmitter. I've got another slide that goes into more detail. But essentially the same thing is that you can use it for spot checking, you can use it on third-party data loggers or SCADA systems, or you can connect it to this Viewlink cellular or satellite transmitter. And then there's other cables and connectors and accessories that to make all of this happen for you that we'll show a slide for here in a minute or two. So here's some of the specs for the RDO Blue. So it's Modbus RS45 output. It ships with the RDO X cap that has a 2-year life on it. There's a 2-year warranty on the probe. All of the cables on the RDO Blue are fixed penetration style cables that are permanently attached to the sensor. However, on the back end, we have 2 types of cables available, stripped and tinned and twist lock, that you can get in 2 different lengths. Now, if you need to go greater than 30 meters, I'll show you in just a minute how you can do that. So that's kind of one of the main differences between the RDO Blue and the RDO Pro X is the RDO Pro X actually had a quick connect directly on the sensor as well as on the end of the cable, where it's potted on this one, which makes it quite a bit less expensive than its predecessors. So anyway, very good accuracy over the range of the sensor, the range being 0 to 60 milligrams per liter or 0 to 600% saturation. So from 0 to 20 milligrams per liter, which is primarily where probably 90% of our customers are working in, they're not getting up into the super saturation. We can give you plus or minus 0.1 milligrams per liter. This is usually better than twice the accuracy of the old Clark cells, the polarographic sensors. And the response time, if we look down there at that, the response time of these sensors are typically twice as fast as the old polarographic or Clark cell technology. And then down at the very bottom, you can see the EPA-approved methodology by EPA number, referencing the standard methods. So here's some of the options and accessories that are available with this. So we have some alternate guards. So if you're placing this thing really deep, we have a weighted stainless steel guard that can go on in the sensor. We have a copper coil that's anti-fouling. So if your fouling is biological in nature, meaning algae, things like this that can accumulate on the bottom of that, putting a copper coil guard on that really helps reduce and minimize the presence of biological fouling on those sensors. Now, if you're in a really extreme environment, we also have an alternate guard that has an air blast kit. So this is a guard that screws on the bottom of the sensor, has a nozzle that's pointed out across the sensor, and then has a barbed fitting on the other end. So you would connect an onshore air line to that, and then you would have compressed air and then something that you would provide that would turn that air on and off to blast across that sensor face to remove any type of sediment or biological fouling that would appear on there. Now, in a previous slide, I mentioned that there was a 10-meter and 30-meter cable options for this. So if you need to extend those, we have this cable extender that can pop in the top of this. This is a waterproof connection. And then on the other side, you can get whatever length of cable you want, up to about 4,000 total feet. We have some calibration kits that consist of a little air compressor and a bubbler situation, so you can create a water saturated with air, 100% environment. And then we have 2 types of communication kits. One of them is the wireless Trocom, which is a Bluetooth battery pack. So if you're wanting to use your Android or iOS smartphone or tablet to either calibrate it or take spot readings out in the field, that's one way to do it. If you get the option with the stripped and tin leads, then we have a USB communication kit that you would just wire those leads into, and then it gives a USB connection to a computer, so you can just use your software on your computer to calibrate the instrument. And then we have the remote telemetry option with the Viewlink cellular and Iridium satellite transmitter that we'll talk more about in just a minute. Anyway, let's talk about price. The RDO Blue is a great value, so you can get the RDO Blue for $795 with a 10-meter cable or $995 with a 30-meter cable on it. What I have circled in the middle of the screen there is a really great price on a bundled package. So if you're somebody where your primary use or even your secondary use is just to go around and do spot checks, kind of a dip and test with the RDO Blue, with a wireless Trocom, which again is the Bluetooth battery pack and your own cell phone, you can get into that for $975. So that would be your portable dissolved oxygen and temperature system. Now, why I'm saying that $975 is such a great value is if you look at the price of the wireless Trocom just by itself, so if you were just to pick it up alone, it's $595 all alone. So that bundled with the RDO Blue is a really good package price. And then beneath that, you can just see some of the prices for the options and accessories. Now, when we were looking at the price there, you saw that there were what we call twist connect or twist lock cables and stripped and tinned cables. So on the right, it kind of shows an example of the stripped and tinned cables. So you just get the cable with bare wire leads, the assumption being that you would have terminal posts on your data logger or your SCADA PLC that you would wire that directly into. If you want to have the added advantage of having it attached to your data logger and PLC, yet still carried around with the Bluetooth battery pack paired with your smartphone, then it's best to get it with the rugged twist lock cable on one end. So even if your data logger or PLC has terminal posts that require bare wire leads, we offer a male mating connector that would be wired into that, and then when you want to carry that around or disconnect it, you just simply undo the quick connect it to your Bluetooth battery pack, or remove the sensor and place another one in use. And then again, if you want to extend the length of your cable, then getting it with the rugged twist lock and the troll cable extender is the way to go. Okay, so I briefly mentioned the Viewlink, and about 8 or 9 months ago, we did another presentation specifically on the Viewlink remote telemetry transmitter. But I think it's worth bringing up again. You can get this Viewlink in two different types, 4G LTE cellular Viewlink or Iridium satellite if people need to have temperature and DO measurements made where there is no satellite, where there is no cellular communication. Both of these are battery powered with either alkaline or lithium D batteries, and we're talking battery lives of years on this. And you can set these up so that they will send you a text message on an alarm condition. So you could specify, hey, in my pond, if dissolved oxygen goes below 4.5 milligrams per liter, I want to get a text message telling me that. So you can set that up on the Viewlink transmitter, as well as you can have it just push data to a cloud-hosted software program called HydroView. So you can have it logging data like every hour, and then once or twice a day, you can push data to this cloud-hosted HydroView program. So wherever you're at, if you have cellular connection, you can just log into that and you can see and download your dissolved oxygen readings remotely without having to go on site. The Viewlink transmitter's got a really cool one-push setup. So you just simply attach your sensor, push the button in the middle of the thing, and it'll go out and recognize your sensor, look at the battery, see if you have cellular or satellite connectivity, what the signal strength is, and if it's successfully pushing data to the cloud-hosted HydroView. Now, just a few things to wrap this up. For those of you that need additional parameters in addition to temperature and dissolved oxygen, In-Situ also has 3 multi-parameter platforms, the Aquatrol 400, 500, and 600 series. And we can measure those parameters out to the right. So quite a lengthy list there. The Aquatrol 400 comes with a fixed suite of sensors. These would be level, water temperature, pH, ORP, conductivity, and dissolved oxygen. And on the Aquatrol 400, pH and ORP is the only sensor that's removable. On the Aquatrol 500 and 600, you basically, I use the comparison of a pizza, that you basically just build these up with the toppings of your choice. So you can say, okay, I want turbidity, dissolved oxygen, temperature, pH, and a central wiper on there. Or somebody may want a chlorophyll A sensor added to it. And with the 500 and 600 series, you also have the added option of a centrally located wiper that can be programmed to clean or sweep the sensors before every measurement is taken or at a timed interval that you would specify. And then finally, too, we have a lot of water resource instrumentation. Over the years, we've built up a really good suite of water level sensors, flow meters, data loggers, automatic water samplers, acoustic Doppler devices for stream and river flow measurement, even underwater ROVs. So if you want to have a video or pictures taken of a tank or of a dam face, we have those. We also have pipe crawlers, all kinds of technology for underwater videography. And then I just want to introduce some of our upcoming water resource webinars that will be going through the rest of this calendar year as well as the first quarter of 2021. So you can see that we have a webinar specifically on underwater ROVs. We have one on mapping manholes with handheld LiDAR, software for measuring, and looking at data from your water distribution and wastewater system. So lots of options there, and if you or colleagues are involved in that kind of work, we encourage you to register for those webinars. Okay, I'm going to open this up for questions right now, so let me pop down to our question pane here and give you a chance to go ahead and type those questions in there. If you have any that come up later, or you would like to have data sheets or specifications emailed to you or a price quote on any of those, you may contact either myself or Martin Soto, my colleague in our Idaho office. Both of our contact information is there below. Wow, looks like I was really effective in presenting this. Oh, there's actually one question that popped in. Let me see if I can read this. Can you give a little more information on the anti-fouling? Yes. So there's basically two technologies that we offer for anti-fouling on this. The most simple and least expensive is probably the copper coil. So essentially you have a sensor guard that goes over the end of the RDO sensor, and it's wrapped in copper wire. And it's been shown that copper, I don't know the exact chemical process that's going on, but basically the presence of copper inhibits biological growth on hardware. So that's one technology there. It's basically a sensor guard that's wrapped in copper wire. So just I think it's the decay of the copper over time that basically prevents biological growth buildup. Now the other one was the air blast kit. So you essentially have a guard that goes on the end of the sensor. Embedded in that guard is a nozzle that points across that sensor, and then on the outside of the guard is a barbed fitting where someone would attach an air line from some compressed air source. And then again, we're providing just the guard and the nozzle with the fitting. The airline and the source of compressed air would be provided by the user and would need to be toggled on and off by a data logger or your PLC to your SCADA system on the shore. So for example, once every hour, that would be kicked on and a blast of air would shoot out across the face of that sensor and essentially remove anything that was building up on it. So I hope I answered that question adequately, but yeah, those are the two technologies that we offer for that. Okay, any other questions on there? That was a great question, Scott. I appreciate that. Okay, well, it looks like that's the only question that I'm seeing in our pane here. Thank you very much for taking time out of your day to attend our webinar. I hope you felt the time was beneficial. And if so, we hope to see you on other ones. Our GoToMeeting program will automatically send out a follow-up email where you can put any of your input or questions into that, but we're happy to hear from you with a phone call or a direct email to either Martin or myself as well. So thank you very much. We'll go ahead and end the webinar for today, and thanks for attending.